in continuing with inverse functions, let's determine if f of x, which is 4x minus 7, and g of x, which is x plus 7 over 4, are inverses of each other. So let's find out if f inverse is actually g, and if g inverse is actually f. Now, once again, we're going to speed through this. What are the domains and ranges of all these functions? Well, there's no radical in either one of these, so you can't have a square root of a negative. There's no fraction or division, so we can't divide by 0. The domains of both of these and the ranges of both of these are both all real numbers. So, of course, the domain of f is equal to the range of f, and the domain of g is equal to the range of f, because it's every one of those four sets is all real numbers. Well, let's determine this now. F of g of x. So I'm going to input, or I'm going to, let's see, the function f is here. I'm going to evaluate it at g of x instead of x. So I'm replacing the x with g of x. So this would be 4 times g of x minus 7. 4 times g of x minus 7. So now let's just do substitution. G of x is x plus 7 over 4. So 4 times, instead of g of x, I put x plus 7 over 4. And then we have that minus 7 right here. Well, hopefully we could do this in our heads. What's 4 times this fraction? Well, the 4 cancels with the denominator 4, because remember, 4 is just 4 over 1. 4 goes away when we cancel them, and you have x plus 7 minus 7. And that's what we were hoping for if we wanted them to be inverse functions. And usually for the functions we're doing in this section, you only need to do one of these. We will find that f of g of x equals x, and for the functions we're looking at, g of f of x will also be x. You don't have to do it in both directions unless the instructions explicitly say to do that. Okay, so here we're going to plug f of x into the function g. Well, here's the function g. So I'm going to replace x with f of x. F of x plus 7 over 4. But now let's substitute, because we know f of x is 4x minus 7. And plus 7 over 4. So all we did is replace f of x with 4x minus 7 in parentheses. Now, can we do this in our heads? The numerator is 4x minus 7 plus 7, so the minus 7 plus 7 goes away. That's a 0. And we get 4x over 4. And the 4's cancel, and indeed, we get x. So the answer, I should have a question mark there. The answer is yes. Those functions are inverses of each other. And it's difficult to just choose an inverse of a function without working it out. But you shouldn't be surprised. Over here, we're subtracting 7 somewhere. Over here, we're adding 7 somewhere. Over here, we have a multiplication by 4. Over here, we have a division by 4. So you shouldn't be too surprised. I would have known instantly if we had 4x minus 7 and said maybe x plus 11, that they're not going to be inverses of each other. Okay. Now, that was the easy part. Determining if two functions are inverses of each other, very simple. You just compose the functions. And if you get out x, they're inverses of each other. If you get something different than x, they're not inverse functions of each other. Okay? The tougher one, but it's not bad, is being given one function. And you need to find the inverse. All right, so we're going to write down the recipe of how to find the inverse of a function. And while we're writing the recipe down, we'll also work it out with this function. F of x equals 4x minus 7. Okay, yes, we just saw that. So we actually know what the answer is going to be. What is the inverse of the function 4x minus 7? It is the function, this one, g of x from above. So we will see that again. Okay, the first step replace f of x with y. Very simple. Y equals 4x minus 7. Step 2, also very simple. Interchange or swap x and y. So you change the y into an x, and whatever x's there are over here, you turn them into y's. So it becomes x equals 4y minus 7. Number 3, and this is the only step that requires any math or arithmetic, solve for y. So if we want to solve this for y, let's see, maybe I don't want to go down too much here, so I'm going to start over here. X equals 4y minus 7. So solving for y, I'm going to add 7 to both sides. X plus 7 equals 4y. And I can simply divide both sides by 4. And what do I get? Let's see, those 4's cancel. I would get y equals x plus 7 over 4. That should look familiar. And the step 4 is very trivial. Just replace this y with f inverse of x. So replace y with f inverse of x, the inverse function of f. So step 4 gives us f inverse of x is equal to x plus 7 over 4. 4 simple steps. And notice that is exactly what we expected. The function, the inverse function of 4x minus 7 we saw was g, which is f inverse of x plus 7 over 4. Okay, let's do a couple more. Number 6, find the inverse if it exists. Not every function has an inverse. And you would discover it during these 4 steps if it didn't have an inverse. Find the inverse if it exists of f of x equals x cubed minus 6. So step 1, replace the f of x with y. Y equals x cubed minus 6. Step 2, interchange x and y. So x equals y cubed minus 6. And now we do the math, the arithmetic. I'm going to start it up here. Step number 3, solve for y. So let's see, what's y cubed equal to? We'd add 6 to both sides and we get x plus 6. And then we need to, we're still in step 3, we have to solve this for y. So how do I get rid of the cubed on that side? What do I have to do to both sides? If I'm raising it to the 3rd power, I need to take the, instead of cubing it, I need to take the cube root of both sides. All right, so that's going to become y equals cube root of x plus 6. And then step 4, which is trivial. Replace that y with f inverse of x. Now, I'm not sure if I need to review this or not, what we just did. If you prefer exponents over these radicals, I could have gone from y cubed equals x plus 6. Well, taking the cube root of both sides gave me, let me just make a note down here, cube root of y cubed is equal to y. Okay, they kind of cancel each other out in that case. That's marker's not very good. Or you could do this, which is effectively doing the same thing. If you raise both sides to the exponent of 1/3, that does the same thing. Because remember, when you have y to an exponent and the whole thing raised to another exponent, you multiply the exponents together. 3 times 1/3 is y. So we can write the answer like this, or another way of writing it is f inverse of x equals x plus 6 to the 1/3 power. These are equivalent. Both are perfectly acceptable, whichever you prefer, radicals or fractional or rational exponents. All right, one more in this video. Find the inverse, if it exists, of, this one looks simple, f of x equals x squared. All right, number 1. Replace f of x with y. Okay, so step 1, y equals x squared. Step 2, interchange them. So x equals y squared. Step 3 is solve for y. So take the square root of both sides and you get y equals radical x. Step 4, f inverse of x equals radical x. Now, did I do anything wrong in these 4 steps? Well, step 1 is perfectly fine. Step 2 is perfectly fine. Step 3. How do I really solve this? Remember, we're going to use the square root property. If I have something squared equals some other number or variable x, when I take the square root, I have to put a plus or minus on the other side. That's the square root property. Plus or minus. Plus or minus. This is not even a function. Okay? Because I could take, let's just take a couple of ordered pairs. If x is 4, we would get, just for example, that gives us y equals plus or minus, what's radical 4? 2. So 2 ordered pairs here would be 4, 2, and 4, negative 2. We have 2 ordered pairs with the same first component and different second components. Okay, so this is not even a function. I'll just make a note, not a function. So I'm going to say D in E does not exist. The inverse function of this does not exist. We'll talk about that a little bit more in a future video.